I'd like to tell people algae's not bad. It's good, and there are good things that can come from it. And then on the bioenergy side, we can make a great product, and it's not necessarily to completely overturn our lives and our use of petroleum. It's to slowly bring those things in to replace a finite resource.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about a deeper role for algae. Whether it's out in the ocean or grown in a lab, algae could be the answer for a lot of our sustainable energy needs. This country isn't the leader in algae production. My guest says there are many countries out there growing it for food in particular. But there are efforts underway, including a multi-cabinet level public-private initiative to produce aviation fuel from biofuels. There isn't an EV equivalent for an airplane. And the work is happening on a smaller scale as well. My guest says their group at the Department of Energy recently awarded several prizes to entrants as young as high school. And it wasn't a science fair. The winner of this prize, she says, has a sustainable solution for algae that is essentially commercial now. It's efforts like these, from classrooms to corporate boardrooms, that are providing algae alternatives as a viable option. My guest today is Christy Sterner, Technology Project Manager at the Bioenergy Technologies Office at the Department of Energy. Their office, which they call BETO for short, is running that Sustainable Aviation Fuel Grand Challenge. But just before our interview, BETO had awarded 5 teams for their Algae Prize Challenge. The winning team, called Kelp I Need Some Algae, was from the University of Alaska in Fairbanks. They developed a natural, biodegradable alternative to the synthetic vinylon string used to grow sugar kelp. They also identified an inexpensive, available, and effective alternative fertilizer for growing that kelp. This was one of those interviews, and I'm noticing this a little more often, where I found myself veering way off my prepared questions and asking a ton of questions inspired by my guests. Maybe I'm getting the hang of this interviewing thing after all. I hope you enjoy my conversation with Christy Sterner. We're here with Christy Sterner, Technology Project Manager for the Bioenergy Technologies Office, or BETO, at the Department of Energy. And hey, Christy, let's talk about algae. Is it a more efficient biofuel solution than, say, corn or soybeans?
Thank you, Jay, for having me. More efficient is kind of an interesting term. What I'll tell you about more efficient is that algae as a feedstock provides a lot of benefits, including higher yields per acre than traditional crops such as corn and soybeans. It doesn't compete with those food crops for soil because it can be grown on marginal land. It can be grown in brackish, saline, and wastewater. It's a natural carbon sink because it uses CO2 to grow, and you can make multiple co-products from it, including the biofuels that we're talking about. So there's a lot of things that have to do with efficiency there, but I wouldn't, term it all as more efficient. It just depends on what you're talking about with more efficient. And then with the focus on decarbonization across many sectors, including transportation, particularly through forward-looking initiatives like the Sustainable Aviation Fuels Grand Challenge that's going on right now, we'll have to mobilize many types of sustainable produced resources, and algae is one of them. In my opinion, a big one of them.
That's good to know. My family farms, they do corn, they do soybeans. I think the idea is we want to try to have that for food. Right?
Absolutely. We're in agreement with you. 100%.
Yeah. And that's something we don't talk about very much, is this idea that algae, we can make biofuel out of it and everything, but algae just naturally, right, can clean up an ecosystem. It kind of has a functional purpose in nature, right?
Absolutely. And, it's a great point because a lot of people think of algae as bad. They think of the harmful algal blooms. They think that it's green or brown or red and it doesn't always look attractive and all those things. But actually, there are a lot of beneficial algae out there that do exactly that. The biggest thing that they can do that a lot of people may not be aware of is it cleans water, because one of the beneficial attributes of algae is that it needs those micronutrients. It needs the phosphorus and the nitrogen, the things that pollute the water. Algae needs to grow. So it uses those things to grow, and you end up with a nice clean water source after the fact.
Christy, I had the Naval Research Laboratory on, I guess, from that. And that was really the first time we'd ever talked about this idea that we talk so much about direct air capture from the atmosphere, where you're taking CO2 out of the air, possibly compressing it and storing it as CO2. But the CO2 in the atmosphere is only like 2% of the CO2 out there. 98% of it is essentially absorbed in the ocean. And so there's this idea, I guess, that you could take that CO2 that's concentrated in the ocean, and it seems to me like algae would be a great idea for a sink for something like that. Right?
Yeah, absolutely. Yep. And that's being explored across the board in lots of different ways, from microalgae to capturing that CO2 and feeding it to microalgae, to also growing more macroalgae, because of course there's naturally occurring macroalgae already in the ocean. But there's this idea of doing macroalgae farms in the ocean that you could capture quite a bit of that CO2 and make useful products from it.
Right. And, one of the things I've read one time was that I think it was like trees, for instance, plants, they become hyper efficient after 450 parts per million CO2. Now, look, we don't want to add more CO2 to the environment, but I'm wondering if CO2 is more concentrated in the ocean, it's serving as kind of a bigger sink for CO2. I guess it's not hurting algae, right? It may actually make it, I think you see where I'm going with this, right?
I absolutely do. And it does. You're absolutely right. So you can't have too much CO2 to feed to the algae, if that's where you're going with it. There's a threshold that they all use it at, but there's so many different types and strains and everything that, you're not going to overfeed the algae too much CO2.
Right. So how far can bioengineering go with algae? How much can you make it more efficient for, say, eating CO2 or maybe living in a harsher environment?
Well, there's a lot of research going on that, and it depends on the strain and what you're trying to get out of it. So bioengineering, of course, can lead to higher lipid content, which can get you more biofuels and plastics and all kinds of stuff like that would be renewable. It can lead you to a higher protein production so that you have more aquaculture feed and animal feed and even possible human feed. And then, of course, you can bioengineer for predation resistance, which increases your yields and your productivity so that you get more algae produced. I mean, it's kind of a wide open door on bioengineering on algae. Of course, that there's always the fact that we do that sustainably, smartly, and economically. And then, of course, with the consideration for the environment, what bioengineering can and can't do. So you want to do it safely as well.
Can you make algae almost secrete biodiesel? And I've also had some guests on who've done things like hardy bacteria that can secrete hydrogen, right?
Right.
How much can you make a byproduct rather than turn it into a byproduct like biodiesel or ethanol the old-fashioned way?
That's a fantastic question. And there are naturally occurring algae strains that do exactly that. There are cyanobacteria, which we consider algae as well, that we include in there that secrete ethanol and can secrete other petroleum-based fuels or replacement fuels. And so it's kind of funny. You can, of course, bioengineer that to happen, but there are naturally occurring ones as well that have been used and researched. So you can take that a step further as well. If you look at the nutraceutical industry, there's a lot of algae out there that produce high contents of EPA and DHA, which are really good stuff for nutrient value, and they make that stuff naturally. And then, of course, if you bioengineer it to make even more of it, it's even more productive. There's lots of good stuff that happens all by itself in algae.
Do we think that it would be better to have the algae live a long life and do those sorts of functions, or do you essentially just want to harvest the algae and then grow a new crop?
You'd want to harvest and grow a new one because, like any biological system out there, there's a maximum. So you have your maximum growth potential in there. They grow to their maximum and then they steady off. And once you get past that growth phase, that's the best time to harvest them and grow some more.
You talked about brackish water environments like that. I grew up in Louisiana, so would go fishing every now and then in that brackish water that was on the edge of the coast. I think in our imagination, we just think that you could grow hundreds of square miles of algae, say, out in the ocean somewhere. Do we think we would do something like that, like large-scale aquaculture out in the middle of the ocean or something?
It's absolutely being explored as an option. Of course, there's a lot of macroalgae that's already grown in the ocean, and it's grown purposely around the world. Not so much around the United States, but certainly out in the world there. And it's very much a possibility. So yeah, I could see algae farms as a way to go in the future, utilizing the ocean and utilizing space in the ocean. Plus, there are other benefits. I mean, it provides food and it provides nutrients and other things for lots of other stuff that lives in the ocean. I mean, there's a lot of benefits to it. So I could absolutely see it.
Two things on that. First of all, let's talk about the biodiversity there. So if you were to go out in the middle of the ocean, for instance, and grow algae, could that potentially be invasive, like kudzu? though? Or do you have to have considerations like that?
Yep,
Okay.
You're absolutely right. Of course, we don't look at or explore or research anything where we don't put that as the foremost thought. We want to do it safely. We don't want to introduce species or grow species that are going to become a problem or invasive. Of course, we don't want it to hurt the existing ecosystem. We want it to help the existing ecosystem. So all of those considerations go in before we would ever do something like that. But I can give you the example. I mean, obviously, kelp and things like that are grown for commercial use, and they're grown very responsibly, and they're done within the rules and regulations of the U.S. to make sure that that happens. And of course, we wouldn't do that. Even if you had hundreds of miles, it would have to have been environmentally friendly and safe.
Yeah. And then I guess the follow up is you kind of touched on this. You said other countries are doing this already. So what are some examples of that?
Well, a lot of macroalgae is grown for commercial use, particularly for food. Thailand grows a lot of stuff, macroalgae, and of course that's grown in ocean water. China, I believe, does as well. There are lots of places in the ocean where this is grown commercially for a crop. You have to deal with temperatures and salt tolerances and all kinds of things that go into figuring that out, which is why it's not as big of a commercial crop around the U.S., but a lot of research is being done to where that could be done in the U.S. and to boost the macroalgae business and commerciability for the U.S. But yes, you can Google it, and there's lots of macroalgae growth going on around the world.
I don't know why we would need Google. This is, you have all that knowledge right now. Hey, so Christy, I think we think algae would just kind of ride the surface, right? Is there any algae that could go below depth? Are there possibilities of maybe growing farms of algae deep underwater?
That's a great question, and algae is kind of funny. So it doesn't all necessarily grow right at the surface. In fact, a lot of your macroalgae, they grow very, very long and tall, which means a good portion of it grows further down from the surface. However, algae need sunlight. You get better productivity as the sunlight goes into the water, and when you start getting down further into the depths where they're not getting that sunlight, it doesn't grow as well. So it just depends on the strain that you have and where you're growing it, what your temperatures are, and what kind of nutrients and sunlight it can get.
Yeah. I was a big fan of that show Sequest back in the day. It was like underwater habitats, right? And
absolutely. Well, and there's lots of them, and they're real.
Really? To what extent are we doing that? Like we could basically just have underwater farms.
Oh, I think for algae, you're going to need the surface because you're going to need that sunlight. But there's a lot of research going into, particularly when you're looking at carbon sequestration, there's a lot of discussion about whether macroalgae could be either grown or secured further down from the surface to sequester carbon. So there is research going into that, but it's pretty new research that's going on. But as far as farming, this is my opinion. And of course, with bioengineering and things that could change, I suppose, but you can't get too far below the surface or you're not going to get that sunlight.
Understood. So, Chrissy, kind of getting into the algae prize. First of all, why is there such an important need to focus on aviation fuels? I'm seeing this a lot. And I used to work in the coal industry where we were talking about maybe coal to fuel as well because oil prices were going up and everything. But bioenergy generated aviation fuel. What about that?
Well, there's a big initiative from this administration with the Sustainable Aviation Fuels Grand Challenge and Roadmap. And so not only is our administration focused on it, but the aviation sector is one of the sectors that has a large percentage of the greenhouse gases. So they produce quite a bit of the greenhouse gases. Plus, you look at the carbon footprint. It's a big target for reducing those greenhouse gases and reducing the carbon footprint of the aviation sector. And of course, sustainable aviation fuels plays a major role in that. And of course, when you look at cars, you think about electrification. Well, the electrification of the aviation sector is not a near-term solution. That's not happening tomorrow. And so doing sustainably produced hydrocarbon fuels that lead to lower emissions for the aviation sector is a large focus, not just for us, but for the administration and our partners with USDA and Department of Transportation and Department of Defense and all of those. So it's a major focus across the board.
Are you working with some sort of entity that represents all the commercial airlines?
Yep. So the commercial airlines are involved. The FAA is involved. And of course, we have groups like CAFI, CAAFI. They're involved. It's a big effort and it involves just about anybody and everybody who's interested in aviation fuels at all or has anything to do with it, including storage, delivery, specs, you name it, testing, engine testing, everything. There are a lot of major partners involved in this effort.
Right. I think I'm starting to notice when I'm booking flights, they'll tell me that my flight is 200 kilograms of CO2, right?
Yes.
Yeah.
Yep. It's a big deal right now. I know. And a lot of people see that and go, why are you telling me that?
Right. So, Chrissy, at the time of this recording, you'd recently announced some winners for the Algae Prize. What were you asking participants to do with that?
The Algae Prize was this new idea of getting student teams involved and interested in the algae industry. And so we asked students from high school through graduate school to form teams and propose novel research projects to address a lot of the challenges within the algae industry. And we allowed and accepted ideas, everything from strain selection and production through processing of those strains and then novel product development. So we wanted to see what other products could you make, what tools are out there available to help the industry and things like that. So it was pretty wide open for teams across the country. And once we made our initial selections, they had a year to perform their research projects, all culminating in the Algae Prize weekend, which wrapped up about a month ago.
Yeah. The other thing I've noticed with a lot of DOE prizes is there can be private companies, public companies, I guess. This was super focused on schools, right?
Yes.
Academic industry. Why that not maybe private or public industry?
Well, because, of course, DOE runs a lot of funding opportunities and workshops, conferences, and other funding mechanisms out there for industry, academia, the national labs and things to compete for and participate in. And we really wanted to focus on the STEM idea, plus to get students involved and to get younger generations more excited and interested, not only in STEM type activities, but particularly with algae. And so you bring a whole fresh new group into this and they come up with some, I can't even tell you from these projects how many amazing cool ideas these folks came up with. So we wanted to focus there and bring a whole new group in.
Absolutely. And so the winning team was out of the University of Alaska.
Yes.
Which is interesting of itself, right? You're thinking like, man, not a lot of sunlight. So what set them apart?
So I was just thinking when you were asking this question, I was thinking, your previous questions were a great lead into this because of what the University of Alaska team is doing. They are dealing with macroalgae and they are dealing with growing macroalgae in the ocean outside of Alaska. And as far as setting them apart, it was a super difficult, tough competition. The 15 finalist teams were amazing. They were all super professional, had great projects, good results. The University of Alaska team are dealing with a project. Not only are they super familiar with because they are a hands-on team, this is what they do. The research that they were performing is right in line with their interests, their jobs, where the industry is in their area. They had partners available that could help them when they reached challenges like going out and trying to get this macroalgae to grow and to maintain through severe weather and big waves and freezing and all kinds of stuff. It was amazing the challenges that they had and how they were able to overcome them and still get really fantastic results. I think that what they have done will lead to very near-term commercialization for what they are researching and what products they can put out there. So it had just an immediate impact and can really help folks up there. Plus, it will expand the macroalgae industry across the United States.
The finalists, two of them had technologies that help basically identify algae features, almost kind of like maybe genome. What did they do and what would be the benefit of that?
They were actually also very cool, very successful projects. And the reason we were looking for new tools available in this system is that if you can learn more about the algae while they're growing real time, you can tweak the systems to get your algae to produce more lipid or more protein or more carbohydrate. You can also look for predation so that your algae ponds or your algae systems don't crash and then you have just a wasted product there and you have to start over. So having tools out there that can monitor your systems, monitor your algae and the system around it, the ecosystem around it, everything involved in that so you can make real-time decisions is really critical to the success of algae commercially. Both of these projects, the Algae Rhythm and the phycosite, are looking at real-time mechanisms to do analysis on your algae system while it's actually growing. Huge impact to the industry. If they can get these to work, it would make a huge impact. There's also on the Algae Rhythm one, it's also a mechanism for teaching and for learning for high school students, which is super exciting. Again, stimulating that STEM activity and getting folks interested and excited about algae. Very cool.
And then the last two finalists, the runner-ups, they had technologies that really, I think, were focusing on byproducts.
Yep. One of the teams was looking at a way of using sargassum, which grows naturally and can be a very large crop that you see showing up on the beaches. A lot of times that macroalgae you see along the edge of the beach is sargassum, and it can be a huge crop and issue to deal with if you don't know what to do with it. And so they were looking at sargassum for making a biocomposite material for 3D printing. They actually took the sargassum, dried it, got it into their system, made some products in their 3D printer from it. Really cool, really innovative. I have to admit, I had never heard of doing that before. And with the growth and increase in the 3D printing industry and where that can lead, just amazing. And then the UC Davis giant kelp team, they were looking on building a sustainable function-based extraction extraction method to produce algae compounds with desired properties. And again, this has a potential to make a big impact on the industry because, of course, you want to take your algae and extract all the useful things out of it. And then the residual that's left, you can still make very useful stuff from that as well. And so finding a sustainable and effective extraction technology is a big, big deal in the industry. There's lots of extraction technologies out there that work to some extent, but algae has its own unique challenges. And so this is a big area, and they were very successful in the technologies that they came up with.
Well, really exciting all around. And Chrissy, I know you've been in this department for a while. You've probably seen a lot of different things. And I asked the same question I asked when I had on the Geothermal Technologies office. Another group within DOE doing a lot of renewables, and it seems like a lot of the thunder is taken up with wind and solar. So when you talk about what you do with people, dinners and whatnot, what do you think are some of the misconceptions? And what do you think one of the big things you like to educate people about what you're doing? What do you find yourself explaining to people the most?
Well, on the algae side, I think the misconception is that algae is bad. All algae is bad and that we have to get rid of it and that it hurts everything and it harms the environment. And it's just not the case. There are harmful algae out there. And even those, if we can find a way to collect those without causing any additional harm or hurting the folks collecting it, if we can find out how to collect harmful algal blooms, we can use those as well. I mean, they have a lot of beneficial things in those systems as well. I'd like to tell people algae's not bad. It's good. And there are good things that can come from it, especially if you look at the protein side and what that could do for feeding the world on the protein side as we move forward and there's population increases and access to protein decreases. Algae is stock full of protein. And then quickly on the bioenergy side, there's a lot of misconception too that bioenergy is out there to take over petroleum. It's not to take over petroleum, it's to replace our dependence on petroleum. If you look at petroleum as a finite resource, then we're going to have something in its place that makes sense that we can do. And so if we can do that sustainably and economically and environmentally sound, we can make a great product that replaces everything that we use petroleum for, which is ultimately the goal. And so looking at renewable resources and bioenergy technologies is a good thing. And it's not necessarily to completely overturn our lives and our use of petroleum. It's to slowly bring those things in to replace a finite resource.
So what's next for the Bioenergy Technology Office? You had the Algae Prize. It also sounds like the aviation effort is really big. So what other things are keeping you busy right now?
Oh, goodness. Algae Prize. Awesome. So we're already planning the next round. We plan to release it in September and October of this year. There should be some brief announcements coming out about that very, very soon, just so folks know about it, can start on that. We've been working with the Sustainable Aviation Working Group to detail out the roadmap so that folks will have an idea of where we're at and whether we can meet the administration's goals and what replacing aviation fuels might look like for the future. Big one is that we're hosting a workshop in early June to develop purpose-grown energy crops for sustainable aviation fuel. And that's because it's going to take all kinds of feedstocks to make this happen and make it a reality. So the answer isn't solely, say, like corn stover, wheat straw, or wastewater, or algae. It's all of those things together. And so this workshop will address that and how we address all the different feedstocks that we have available. These are just the big initiatives we have going on right now in the area that I work in. Bioenergy Technologies Office has lots of other programs besides the one I work in that there's just so many amazing things going on. We have an entire scale-up program that's looking at taking all of these very cool new technologies beyond pilot scale or to pilot scale and then demo and eventually to make them commercial. So lots of cool stuff going on in bioenergy right now.
Very cool. All right, Chrissy Sterner, Bioenergy Technologies Office, Department of Energy, thank you so much for your time.
Thank you, Jay. I really appreciate it. This has been a great experience.
That was Christy Sterner, Technology Project Manager at BETO, the Bioenergy Technologies Office at the Department of Energy. I want to thank Christy for her time, as well as John Horse at the Department of Energy. I believe this is my 5th interview working with John, and we appreciate all he and the department do for the show. You can find plenty of pictures for this episode on energy-cast.com, as well as Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 166. Be sure to join us next week when we meet one of my old bosses and discuss the journey they've taken to build a solid-state circuit breaker. Until then, I'm Jay Dowenhauer. We'll see you next time.